Welcome to Pop-Up Perspectives with Perficient. Today I'll be discussing an AEM Security topic, preventing cross-site scripting. Large-scale data breaches and critical security vulnerabilities have companies thinking about security more than ever. Many developers are familiar with cross-site scripting already, but are they familiar with the tools within AEM to help prevent it? Let's jump right in. As a quick review, cross-site scripting or other security issues can occur if user-entered inputs are not filtered before displaying back to the user. Remember that user-entered content can include sources that usually users do not edit, like URL parameters, local storage, and cookies. Many applications will also need to filter user content from HTML and JS emails before sending. When using HTML tags in AEM, the default rendering context and all other contexts other than unsafe will utilize a set of OWASP rules called anti-SAMI. Sometimes this rule set may filter more than expected, and some developers resort to using the context unsafe attribute, which renders the raw text from the Sling model property. So let's look at a common problem in AEM implementations. The default anti-SAMI library interferes with telephone or tel hrefs and links. For instance, this code will not allow model URL equals tel and then a phone number to be output correctly to the page. A developer might just resort to including context equals unsafe, or worse, replace the anchor tag with an open RTE. Thankfully, we have a few options other than using context equals unsafe. Design your components to utilize feature flags for hard-coded attributes, or output special characters separately from the user or author input. You can also overlay the default rule set for the anti-SAMI rules located at libcq cross-site scripting protection config.xml. Be careful not to allow any more attributes or special characters than you need, or any of the ones commonly used by exploits to run JavaScript. Thirdly, you can utilize a custom backend service or static utility that rewrites entered characters to desired substitutes other than empty. My preference out of these is number 1, so I'll provide an example. With these considerations, your implementation may look more like the following. It's a bit complex, but straightforward once you examine it. The first anchor tag will show in the case that the link is not a phone link. This could be determined by a checkbox in the component dialog and a mapping in the Sling model. The second anchor tag will show in the case the link is a phone link and is a valid phone number. This can be determined by the previously mentioned checkbox in the dialog and a phone number validation function within the Sling model. This anchor tag includes the tel prefix to the link and an optional extension. We want AEM's link checker to skip checking the validity of this link, so we include the XCQ link checker attribute in the anchor tag. Finally, we have a div tag where an error message would display if an invalid phone number is authored. This section is optional and depends upon your business requirements. Do you have any context equals unsafe usages in your codebase? It's worth checking to see if it's exploitable. But it's only the start of the cross-site scripting vulnerability review process. For more information on how Perficient can help you achieve your AEM security goals and implement your dream digital experiences, we'd love to hear from you. Thank you for joining us for this episode of Pop-Up Perspectives with Perficient.